dilute HNO3. Okay, in dilute HNO3, what is going to happen? I will get two products, OH, which is ortho substituted, plus phenol, which is para substituted. Okay. So again, here, this is the major product. Okay, this is the major product, para substituted one. Now, in nitration, there is a difference between ortho nitrophenol and paranitrophenol. Okay. What is the difference? Ortho nitrophenol, it has what? It has intramolecular hydrogen bonding, and paranitrophenol has intermolecular hydrogen bonding. Okay, so please write here. O-nitrophenol has intramolecular hydrogen bonding, P-nitrophenol has intermolecular hydrogen bonding. Okay, intermolecular hydrogen bonding. Okay, so I will show you guys also. So this is the hydrogen bond here. इसको थोड़ा this is the hydrogen bond here, and if I talk about the para substituted one, तो उसमें कुछ इस तरह से आप देख लीजिए. Oxygen here. This oxygen can have a hydrogen bond with another OH of another paranitrophenol, है ना? So intermolecular, as you can see that it is using how many molecules? 2 molecules, but intramolecular it is having the hydrogen bond in only one molecule, on its with itself only. Therefore, now the molecules of O-nitrophenol, they have molecular hydrogen bonding intramolecular. That means they are not interacting with, they are not having any attractive force with any other O-nitrophenol. O-nitrophenol के दो molecules के बीच में उतना attraction नहीं है. P-nitrophenol से molecules के बीच में attraction है. Okay, and therefore O-nitrophenol it will have or rather I should write O-nitrophenol is more volatile than P-nitrophenol. And these are separated by steam distillation. देखिए इसको आप रिलेट कीजिए एजियोट्रोप में हमने बताया था आप लोगों को, if we have to separate anything, then what we need to do, we need to distill it. And what is the main criteria for distillation? Those two substances which are to be distilled, they should have a difference in their boiling point. And since O-nitrophenol is more volatile, that means it will boil off easily. O-nitrophenol will boil off easily. P-nitrophenol will not boil off very easily because it has hydrogen bonding. That is why O-nitrophenol and P-nitrophenol, we have a mixture. We will start heating it. And then what is going to happen? O-nitrophenol will evaporate. It will get condensed, and we will get the pure O-nitrophenol in one container. in the right hand side of the distillation whole thing, and the main beaker in which we had already put the mixture, we will be remaining with only the P-nitrophenol. Okay, so write this down. This is one of the questions that they can ask. How will you separate O-nitrophenol and P-nitrophenol? That is one thing they can ask you. And they will ask you like, why is O-nitrophenol more volatile than P-nitrophenol? So for both of them, you have to answer that O-nitrophenol has intramolecular hydrogen bonding, P-nitrophenol has intermolecular hydrogen bonding. Show them by the diagram, then write the conclusion. That is why O-nitrophenol is more volatile than P-nitrophenol. Okay, and then you will write that they can be separated by steam distillation. Please write this down fast. I hope you have written the structures. Then you will write for concentrated HNO3. This is a dilute HNO3. Okay. It leads to formation of tri-substituted product. And the OH acetate. Okay, so this is 2,4,6 trinitro phenol, aka this is also known as picric acid. Achha, one more thing, this is done in the presence of H2SO4. Please let me know if you're done, guys.
डन सर।
डन, ओके। अब देखिए एक ऐसा चीज है ना, एनसीईआरटी में देखिएगा, they have also given modern method of preparation of picric acid. Okay, so right, modern MOP of picric acid. अच्छा, उन्होंने टेक्स्ट में लिखा हुआ है कि ऐसे ऐसे रिएक्शन करते हैं, पिक्रिक एसिड बनता है। एंड व्हेन यू रीड द एनसीईआरटी लाइन बाय लाइन ना, तब आपको पता चलेगा। वो फिर पूछते हैं कैन यू प्लीज राइट द रिएक्शन फॉर ऑल ऑफ देम ना। सो दे हैव नॉट गिवन यू द रिएक्शन, बट दे हैव आस्क्ड यू टू राइट द रिएक्शन. दैट इज व्हाई एनसीईआरटी, if you just read NCERT without a teacher or without any other book, then it is not going to help you. Okay, so NCERT is a book mainly for the teachers, so that they read the textbook. Then अब जैसे ये है मॉडर्न मेथड ऑफ प्रिपरेशन ऑफ पिक्रिक एसिड, इसके रिएक्शन नहीं दिए हुए, लेकिन ये वर्ड दिया हुआ है यहाँ पे, है ना। अब सीबीएसई सवाल कर सकते हैं. So what is the modern method of preparing picric acid? First of all, we take phenol. And we do sulfonation for phenol. That means we'll be reacting this with concentrated H2SO4. Okay, concentrated H2SO4. Then what we are going to get? We are going to get two products: ortho substituted sulfonic acid and para substituted sulfonic acid. So we'll make both the products. First of all, we'll make ortho SO3H plus para substituted SO3H. Okay. Now, once we have done this, then we do nitration of the sulfonic acid in concentrated H2SO, in concentration HNO3. and what do we get here? We get picric acid. ठीक है, कैन यू सी दैट दे हैव आल्सो मेंशन्ड सल्फोनेशन, है ना? तो सल्फोनेशन ऐसा टॉपिक उन्होंने नहीं दिया, बस दो ही टॉपिक दिए उन्होंने, ब्रोमिनेशन दिया, नाइट्रेशन दिया। नाइट्रेशन के अंदर उन्होंने छोटा सा रख दिया, मॉडर्न मेथड ऑफ प्रिपरेशन ऑफ पिक्रिक एसिड इज दैट वी फर्स्ट ऑफ ऑल डू सल्फोनेशन फॉर phenol and then we react that benzene sulfonic we have this phenol sulfonic acid, right? We react phenol sulfonic acid with concentrated HNO3 to get picric acid, है ना? So here they have also mentioned sulfonation. ऐसा नहीं सल्फोनेशन नहीं है, सल्फोनेशन भी है आपके सिलेबस में। ओके, चलिए, डन? यस और नो प्लीज टेल मी।
डन सर।
डन, ठीक है, चलिए। अब देखिए एक सवाल लिखिएगा, दिस क्वेश्चन इज वेरी इंपॉर्टेंट। Write structures of major product expected from the following reactions. First of all is mononitration of 3-methylphenol and dinitration of 3-methylphenol. So first of all, let us see what is 3-methylphenol. OH, and in the third carbon we have CH3. Okay, third carbon we have CH3. Now you have to understand one point very effectively. ये जो OH होगा इस तरह से. Please don't write anything. And the CH3 will be something like this. Right? Can you see that there is no, literally there is no space here? Can you see that? Yes or no, tell me.
So can you repeat what you say?
I'm saying that if you see this place, there is no space here, right? Correct?
Yes, sir.
And that is why when we are doing, first of all, let us see mononitration. So one nitro group, mononitration. Now what are the, यहाँ पे आपके पास product बन सकता है, here we can make a product. Why? This is ortho to OH and it is what? Para to CH3. No, it is para to CH3. That is why we can, है ना, मेरा तो product बनता नहीं है because both of them are what? Both of them are plus M group. OCH3 is also plus M, OH is also plus M, and CH3 is also plus M. That is why they will be making what product? They will be giving you a product which is valid for both of them. So यहाँ पे we have OH and here we have what? Here we have OH and here we have CH3. इसके लिए क्या हो जाएगा ये? Ortho, इसके लिए para. Similarly, I can get this product also, which is going to be para for OH and ortho for CH3. तो जो दो product मिलेगा हमको, those two products will be OH, NO2, CH3, because I will be getting OH, CH3, NO2. Now this position was ortho to both OH and CH3. It was valid thing, but due to steric hindrances, what is happening? This is, we are not getting any nitro product here. Okay, but what is going to happen if we do dinitration? That means what we are using here in mononitration, we are using dilute HNO3. Dinitration in which we are using what? Concentrated HNO3. Now, if we are doing concentrated HNO3, then we'll get only one product, and that product will have CH3, NO2 in this position, and NO2 in this position, right? Okay, this position is what? It is meta to both of them. OH के लिए भी meta है and CH3 के लिए भी meta है, right? See 1, 2, 3, है ना? 1, 2, 3. So it is meta for both of them. That is why it is not reactive, है ना? It is not reactive. It is not activated. So the active points are these blue points where we can have the nitro group. So if we are doing mononitration, then I will get one product which is, अच्छा इसका नाम क्या हो जाएगा बताइए तो? So this is phenol, and which is having 1, 2, 3, 4. It will be long. कहाँ से चलने से ज़्यादा बेहतर होगा? 1, 2 phenol ना 1 2 3 4 5 अच्छा यहाँ से चलेंगे तो 5 नहीं होगा ये 6 हो जाएगा and if I will go from here 1 2 3 4 5 so 2 and 5 हाँ ठीक है JKL and JKL MN so it will be 5 methyl 2 nitro phenol है ना इस तरह से नाम हो जाएगा इसका ओके चलिए फिर इन दोनों प्रोडक्ट को लिखिए कोई डाउट है तो बताइए 5 मिथाइल 1 2 3 4 5 हाँ ठीक है 5 methyl 2 nitrophenol then we will look at phenyl methanoid first of all you have to know how this structure looks like phenyl methanoid then only you can write the product so phenyl methanoid first of all we'll make phenyl is nothing but a benzene ring phenyl methanoid ना हाँ ठीक है फिर ऑक्सीजन आटम ठीक है now can you see that they are doing what they're asking you a reaction है ना जिस किसका ईस्टर्स का एंड ईस्टर्स चैप्टर चल भी नहीं रहा है but still we can answer this we have O and COCH3 is bonded to carbon double bond O CO CH3 now this oxygen atom it is very similar to the oxygen of phenol because this is having oxygen with the lone pair electrons that is why which of the carbons will be activated the activated carbon will be ortho para and ortho so these are the activated ones and they are doing mononitration mononitration में हमारे पास क्या होगा दो प्रोडक्ट बन जाएंगे अच्छा one thing you can see here that this ortho position will be very much sterically hindered so in mononitration I will get only one product that is the para product right so first of all these are what sterically hindered that is why they will be not forming any product and this will be having an O2 group and dilute HNO3 okay right next coal based reaction coal
So
based
can you
reaction
scroll bit up?
हाँ scroll लीजिए
So can you show the question? Done, sir.
let me know if you're done
Done, sir.
done okay right coal based reaction coal based reaction so coal based reaction
Sir, can you
is
scroll up? Sorry. Only this. Done, sir.
clear okay right next coal based reaction right when sodium phenoxide is heated with carbon dioxide, at around 400 Kelvin and 427 atm pressure, sodium salicylate is formed. Which on further acidification gives salicylic acid. Okay, so this is the Kolbe's reaction. First of all, we need sodium phenoxide. So from phenol, we can get sodium phenoxide very easily. We have OH. So do a reaction with, let us say, NaOH or Na also. So if I do a reaction with NaOH, I will be getting sodium and Na, right? Sodium phenoxide ion. Now what we need to do, we need to react this with carbon dioxide, 400 Kelvin pressure, sorry, 400 Kelvin temperature, 6 to 7 atm of pressure, and then it is going to form oxygen, and here it is going to get COONA, COONA. Then with a rearrangement, what happens? This phenol gets hydrogen from here, and this COONA gets substituted here. Okay, now what we need to do now, we need to just add acid, dilute HCl. This Na will be replaced by H. We have OH and COOH. If you write the, if you want to write the IUPAC name, then this can be written as, see, this is benzoic acid, and then we have OH here. So 2-hydroxy benzoic acid. If you want to write in terms of phenol, then you can write what we can write here. We can write 2-carboxy benzoic acid, but generally 2-carboxy phenol, but benzoic acid के रहते हुए, COH के रहते हुए, phenol को हम लोग priority नहीं दे सकते, right? So we'll write 2-hydroxy benzoic acid. This is also salicylic acid. Okay, if you want to write the reaction directly from here to here, oh, can I convert this to anything? So first step is NaOH. Second step is CO2, 400 Kelvin temperature, 6 to 7 atmospheric pressure, and third step is dilute HCl. If you want to write one-step reaction like this. Now let us look at the mechanism here. So we'll start directly with phenoxide ion. So I have ONA, and then I'm reacting with carbon dioxide. So if you look at carbon dioxide, it is very, very, very electron poor. It has oxygen atom with double bond and pulling all the electrons from the carbon atom. So this is what delta positive, highly delta positive. And what do we have? We have the benzene ring here, right? And benzene ring, it has pi electrons. So these pi electrons are what? Electron rich. So what is going to happen? This is going to attack on this carbon atom. And evidently, this oxygen's lone pair electron, it will come to rescue and it will make a double bond like this. So the first step is we get a complex like this. We have a double bond O, right? And here we have COONA. Here what do we have? COONA. Then what is going to happen? Here we have a positive charge, and we have anything? No, we don't have anything here. We have a double bond here. We have a double bond here, and there is a hydrogen here, right? There's a hydrogen here. This hydrogen will come to rescue. This oxygen atom, it is what? It is very much in need of electrons because it has a positive charge now. So it will attack the hydrogen like this. The hydrogen will leave its bond like this, and then this will go and further neutralize the oxygen atom. And now you can see that we are converting this to OH. So this phenomena that I have just shown you, it is known as tautomerism. Okay, so this is somewhat like ketone. This is somewhat like ketone, and this ketone is getting converted into phenol, and then it is forming a double bond here. It is tautomerism, COONA. And then on further acidic hydrolysis, the COONA will get converted into COOH. Now this, see what is this? Carbon dioxide electrophile. So Kolbe's reaction is kind of an electrophilic substitution reaction. Write this down. Then we have another reaction that is with CHCl3, Riemer-Tiemann reaction. Then yes or no, please tell me.
Yes.
Right, next.
Sir, can you
Riemer-Tiemann
scroll up?
reaction. Sure.
That's it.
Please read. When phenol is refluxed with chloroform in the presence of aqueous NaOH at around 340 Kelvin, followed by hydrolysis, an aldehyde group gets introduced at ortho position. At ortho position of phenol, leading to formation of salicylaldehyde. Salicylaldehyde. What is the reaction? In the reaction, we have phenol. The first step of the reaction is that we are reacting this with CHCl3 in the presence of NaOH. CHCl3 in the presence of NaOH. And we also have, you can also write heat here. What do we get? First of all, we get NaOH के presence में क्या होगा? This OH will get converted into ONA, and then here CHCl3 में से Cl will be removed, and I will be introduced with CHCl2. We'll look at the mechanism also. Don't worry about it. We'll look at the mechanism also. Then further, a reaction happens, and since we have many OH groups here, this ONA is as ONA, and this Cl2 gets replaced by OH whole twice. We have CH as it is, and we get OH whole twice like this. Then on further hydrolysis, what is going to happen? अच्छा, यहाँ पे देखें. This is the carbon atom, one hydrogen, one OH and another OH. First class alcohol chapter का कुछ याद आना चाहिए आप लोगों को. If I have, this is what gem diol, right? It is gem diol, and it is getting converted. It will get converted into what? Aldehyde. Automatically, it will get converted into aldehyde. This is still ONA, and we have here CHO, and then on further hydrolysis, an addition of water, ONA will get converted into OH, and this CHO will be as it is. Okay. Write this down, then we'll look at the mechanism. So here we have first step में CHCl3, NaOH, 340 Kelvin temperature. Second step is water. And then all the reactions are happening intramolecularly only, okay? There is not much reaction happening inside here. These are just steps of rearrangement, nothing else. Done, guys? Done, everyone? Yes or no? Please tell me.
Done, sir.
No, sir.
हाँ, ये रिएक्शन लिखना बाकी होगा ना. लिखिए इसको. टेक्स्ट तो लिख लिया होगा आप लोगों ने, है ना? इसको लिखिए. Please let me know if you have written. Done. See, in mechanism, first of all, we have alcohol. Sorry, we have phenol, and phenol is in the presence of NaOH. So that is why this oxygen will get O negative and Na positive like this, right? O negative and Na positive. I'm just removing Na positive because it does not have any role in this case, because you can see we are not forming any CO, any kind of thing. Okay, so Na is just there in with oxygen in all of the steps. So I'm just writing O negative. When I'm writing O negative, you will understand that there is Na positive already there. Now, that is present. Now, don't write now. Okay, please don't write. This is with the phenol. And then we have CHCl3. If you look at CHCl3, it has carbon atom with 3 chlorines. And then there is hydrogen atom, right? Plus we have NaOH. So from NaOH, OH negative will be there. And you can see that there are 3 chlorine atoms. This will be very highly delta positive. And that is why OH negative can easily attack on this H, leading to formation of CCl3. And H will go giving the electrons to carbon atom. So this will get a negative charge. This will get a negative charge. CCl3 will get a negative charge right now. Plus H2 will be formed. H2 is OH negative attacking the hydrogen, which is having very delta positive charge. Now further, what is going to happen? One of the Cl negative atoms will leave from here, and you will get CCl2, which is known as carbene. This is dichlorocarbene. Now this carbene atom, it is electron deficient. Why it is electron deficient? You can see that, sir, lone pair banaya aapne electron deficient kaise hai? It is electron deficient because it is having how many atoms around it? It is having 1 and 2 atoms. That means 2 bonds. 2 bonds mean 1, 2, 3, 4. 4 electrons, 5 electrons, and 6 electrons. That means it is what? It is a electrophile. This is known as carbene. Okay, it is an electrophile. Now the carbene will come and attack. It will get attacked by this benzene ring, because carbene is what? Carbene is electron deficient, Cl2. This will get attacked by this benzene ring. Then oxygen with its lone pair electrons, it will attack and it will form a double bond as always, leading to formation of double bond oxygen with a positive charge here. Okay, and then here there was one hydrogen, and there will be carbon and Cl2. Now still you can see that CCl2, it is what? It will be having a negative charge. Why negative charge? Because it is still not having complete set of octet. It will have Cl2 with a negative charge, and with this negative charge, it will attack on this hydrogen atom. Hydrogen atom will leave all its electron on this bond, and then this bond will break and it will neutralize the oxygen atom. And these bonds are as it is, which will lead to formation of, अच्छा यहाँ पे O negative है तो यहाँ पे positive charge तो नहीं रहेगा. We have O negative. It will form a double bond. यहाँ से आप charge हटा दीजिए. It will again make a single bond O and negative charge here. And this will be double bond, this will be double bond, this will be double bond, and this CCl2 will become CHCl2. Now look what is going to happen. We have CHCl2, and there are plenty of NaOH atoms. Okay, there are plenty of NaOH atoms which will replace this 2Cl2 with OHs. Now the next steps are very easy. O negative, this will convert itself to CHO. Further hydrolysis. Leading to formation of salicylaldehyde. Write a note. You will ask, sir, if it is electrophilic substitution reaction, then why is the ortho product here coming? And it is also a major product. So you'll write here. What is this? We have this benzaldehyde, and this is hydroxy, right? So 2-hydroxy benzaldehyde stabilized by chelation, and hence it is stable. Okay, so what is chelation? Chelation is just a ring formation. So what kind of ring is formed? We have OH, and this carbon has a double bond, O, and hydrogen like this. So this has a hydrogen bond. As you can see, we are forming a 6-membered ring. 1, 2, 3, 4, 5, 6-membered ring is formed when we have the C double bond OH. So this is known as chelation, ring formation. Done, yes or no, please tell me.
No, sir.
Okay, so
what is after stabilized by?
chelation, chelation, CHELATION. Chelation means ring formation. Chelate word is new for you right now because you are learning organic chemistry. Because before part 1, in part 1 you have coordinate chemistry and coordination compounds or coordinate chemistry. In that we have chelating ligands and so things. So उस टाइम अगर आप लोग उसको पढ़ के आते तो उतना नया नहीं होता. But chelation means ring formation, nothing else. Okay. Now for you guys, the homework will be, we have done all the reactions of alcohol, all the reactions of phenol. So your homework will be, prepare a reaction map for alcohols and prepare a reaction map for phenols. Okay. Also, one more thing, I hope you guys remember that next Saturday you have test on haloalkane, halorine. Okay. Declare something, yes or no, please tell me. Yes or no, guys? लिख लिया कि नहीं?
Yes, sir.
Okay. So there are a few things in alcohol phenol में like how to distinguish between primary, secondary, and tertiary. We know it by Lucas reagent. There is also one more test, that is Victor Mayer's test. Then there is oxidation reaction. Then there is reduction with copper metal also, right? We have different types of product that we get. Then we have one, it is known as iodoform test. Then there are some more tests. तो test के बारे में we will do one lecture, not one lecture, एक lecture में सारे टेस्ट को खत्म कराना चाहते हैं. So maybe next we will be doing preparation of ethers and then the tests also. For alcohol, phenols 1 degree, 2 degree, 3 degree, and then what is the test for alcohol versus phenol? Alcohol versus phenol तो काफी easy होता है. Like if you just do a litmus test, then it will be fine. तो phenols क्या करते हैं? Litmus test में blue को red में convert कर देते हैं. Alcohols नहीं कर पाते because alcohols are weaker acid than water also, right? They're weaker acid than water also. चलिए, those things that will learn the next class only. Saturday को ही कर पाएंगे. ठीक है. चलिए, आज के लिए इतना ही रहने दीजिए. कुछ और तो बचा नहीं phenol के अंदर. Everything is done. Please prepare the reaction map and